All right, so let's talk about, those everyday objects,
Mm.
the ones that just seem to appear out of thin air. You know what I'm talking about. Hollow, surprisingly durable, and made of plastic. I bet you've never even stopped to think about how they're made. Well, get ready because we're diving deep into the world of rotational molding.
It's quite a fascinating process, and it really is behind so many things that we use daily. Kayaks, those massive water tanks, even playground equipment.
Exactly. And what's even more intriguing, I think, is the simplicity of it all. Powdered plastic heat, rotation, and cooling. That's the basic recipe. Today, we're going to unpack this manufacturing magic using a comprehensive overview we've got here. And trust me, you'll be surprised by what you learn.
I think what often gets overlooked is just how cost-effective this method is,
Correct.
especially when you compare it to something like injection molding.
Well, that's interesting. I always wondered about the economics of it all. Why is rotational molding so much cheaper? What kind of impact does that have on businesses?
Yeah. Well, it all comes down to the molds. In rotational molding, they're typically made from aluminum or steel, which might sound expensive, but it's significantly cheaper to produce than the highly complex molds required for injection molding. This makes rotational molding a game changer for businesses that need to produce smaller quantities, or even just prototypes, without a huge upfront investment.
So it's not just about saving money. It's about opening doors for smaller companies or even individuals to bring their product ideas to life. That's pretty amazing. Okay, let's break down the process itself. It all starts with the mold, right?
Absolutely. You can think of it as a 3D blueprint of the final product. This mold is loaded with powdered plastic resin. And then the magic truly begins. It's placed inside a giant oven and begins rotating on not one, but two axes.
Wait, two acts. I'm having a hard time visualizing that. It's at like a spinning top kind of motion.
Not quite. Imagine a Ferris wheel slowly rotating, but each cabin on that Ferris wheel is also spinning like a carousel. That's dual axis rotation. And it ensures that the powdered plastic melts and coats every single nook and cranny of the mold with incredible uniformity.
So that's the secret to that smooth, consistent wall thickness that I always notice in these products. Okay, makes sense now. But it also sounds like it might take a while for everything to melt and settle properly.
You're right. It does lead to longer cycle times compared to other methods. That's a factor to consider. But that slow, deliberate process is also why rotationally molded products are known for their strength and durability.
It's like slow cooking. Sometimes the best things take time. And speaking of durability, how can we, the average folks, spot rotational molding out in the wild? What are the telltale signs?
Well, one of the most obvious clues is a hollow structure. Rotational molding excels at creating seamless hollow objects. So if you see something like a kayak or a large storage container, there's a good chance it was made using this process.
And what about those seam lines everyone talks about?
Those can be tricky. While some rotationally molded products will have a visible seam line where the two halves of the mold met, many modern techniques can create a nearly seamless finish. It's not always a reliable indicator.
So if I'm examining a suspect plastic object, a hollow structure is a better clue than a seam line.
Precisely. Another giveaway is that consistent wall thickness we talked about. It's a hallmark of the rotational molding process and contributes to the overall strength of the product.
Okay. That's actually really helpful. I'm starting to see the world in a whole new light now, analyzing every plastic object I come across.
That's the beauty of understanding these processes. It's like unlocking a hidden language that surrounds us.
Absolutely. But let's move on to the pros and cons. We've already touched on the cost effectiveness and the longer cycle times. What other advantages does rotational molding offer?
Well, one of the key benefits is minimal waste, unlike other molding techniques where excess material is often discarded. In rotational molding, the unused powdered plastic can often be collected and reused in subsequent cycles.
So that's why it's considered to be a relatively eco-friendly process.
Exactly. It's a win-win situation, both for the environment and for manufacturers looking to reduce material costs.
That makes a lot of sense. But our source also mentions limited material options as a potential downside. Why is that?
Not all plastics are created equal when it comes to rotational molding. The ideal plastics need to have specific properties, primarily the ability to melt and flow evenly at a specific temperature range without breaking down. This limits the range of materials that can be used effectively.
So it's a bit of a balancing act, finding the right plastic that meets the structural requirements of the product while also being compatible with the rotational molding process. What are some examples of plastics that work well?
Polyethylene is a very popular choice, and you'll often see it used in those large water tanks we mentioned earlier. You've also got polyvinyl chloride, or PVC, which is known for its durability and resistance to weathering. making it a good choice for outdoor products like playground equipment. And then there's nylon, which is valued for its strength and impact resistance, making it suitable for products like kayaks.
It's fascinating how each material brings its own unique set of properties to the table. And the choice of plastic ultimately determines the final characteristics of the product.
Absolutely. And that's why understanding the nuances of the materials is just as important as understanding the process itself.
So it's not just about powdered plastic heat rotation and cooling. It's about the careful selection of materials and a deep understanding of their properties. It's like a recipe where every ingredient plays a crucial role in the final outcome.
Exactly. And speaking of final outcomes, let's take a look at some real-world examples of products made using rotational molding. Our source highlights three key examples: water tanks, kayaks, and playground equipment. Each one showcases a different strength of this versatile process.
Okay, let's dive into those examples, starting with water tanks. What makes rotational molding the perfect choice for these massive containers?
Well, think about the essential requirements for a water tank. It needs to be incredibly strong, completely leak-proof, and often quite large. Rotational molding ticks all those boxes.
Right, that makes sense. We've already talked about that uniform wall thickness and durability that the process is known for. And I'm guessing that seamless construction is key for preventing leaks. It's basically a giant one-piece container, right?
Exactly. And remember those cost advantages we discussed earlier? That applies to large-scale objects like water tanks as well. Using rotational molding keeps the manufacturing costs down, making it a much more practical choice for both manufacturers and consumers.
It's amazing to think that those massive tanks we see towering over construction sites or tucked away on farms are all thanks to this seemingly simple process. Okay, let's move on to kayaks. I've always been fascinated by how sleek and lightweight they are, yet still durable enough to handle all sorts of conditions on the water.
It's a great example of how rotational molding can be used to create complex shapes while still maintaining that strength and integrity. Kayaks need to be streamlined for efficient paddling, and the ability to mold those curves and contours is a major advantage.
And the hollow structure, of course, is what keeps them buoyant. Is there anything unique about the type of plastic used for kayaks?
Well, polyethylene is a common choice, just like with the water tanks, but it's often a specific type called high-density polyethylene, or HDPE. It offers a great balance of stiffness, impact resistance, and UV resistance, which is crucial for something that's going to be exposed to the elements.
So it's not just about picking any old plastic. There's a lot of thought and consideration that goes into selecting the right material for the specific application. Now, to our final example, playground equipment. I remember those brightly colored slides and climbers from my childhood, and they took quite a beating.
That's where the durability of rotational molding really shines. Playground equipment needs to withstand years of enthusiastic use, and the seamless one-piece construction eliminates those potential weak points that you might find in assembled or welded structures.
And I imagine the design flexibility allows for all those fun curves and tunnels and unique shapes that make playgrounds so exciting for kids.
Absolutely. Rotational molding gives designers a lot of freedom to create those playful and engaging environments. Plus, it's a relatively safe option because the plastic is impact resistant and the rounded edges minimize the risk of sharp corners.
It's really fascinating how one process can create such a diverse range of products, from utilitarian water tanks to sleek kayaks to playful playground equipment.
It speaks to the versatility of rotational molding and its ability to adapt to various design requirements and material choices. It's a true testament to the ingenuity behind the process.
It's also made me realize that there's so much more to those everyday objects we often take for granted. There's a whole world of engineering and design behind them. So as we wrap up our deep dive into rotational molding, I'm feeling a sense of awe for the seemingly simple yet incredibly powerful process.
And that's what we hope you take away from this deep dive as well. A newfound appreciation for the hidden wonders of manufacturing and the clever processes that shape the world around us.
Absolutely. But before we completely wrap up, I have one lingering question. We've talked about the various advantages of rotational molding. What about the potential downsides? Are there any situations where it's not the ideal choice?
That's a great question. While rotational molding offers a lot of benefits, it's not a one-size-fits-all solution. There are certain limitations and drawbacks to consider.
Okay, let's hear them. I'm curious to know when another process might be a better fit.
Well, we've already touched on the longer cycle times, which can be a drawback if you're looking for high-volume production. And the limited material options can be restrictive if you need a very specific type of plastic or a unique combination of properties.
So if speed and material versatility are top priorities, rotational molding might not be the best option.
Exactly. And another potential issue is the possibility of defects. While rotational molding is generally quite reliable, things can go wrong during the process, leading to inconsistencies in wall thickness or surface imperfections.
I imagine those issues are more likely to occur if the process isn't carefully managed and monitored.
Precisely. Maintaining consistent temperatures, ensuring proper mixing of the plastic powder, and meticulously inspecting the molds are all crucial for preventing defects and ensuring high-quality products.
So there's definitely a human element involved as well, making sure everything runs smoothly and the quality is maintained. It's not just about machines and automation, it's about skilled technicians and careful oversight.
Absolutely. And that's an important aspect of any manufacturing process. It's that combination of technology and human expertise that ultimately determines the success of the final product.
So we've covered the basics, the pros and cons, and some real-world examples. What key takeaways do you think our listeners should walk away with from this deep dive?
Well, I think the biggest takeaway for me is that rotational molding, while seemingly simple, is a surprisingly versatile and sophisticated process. It's not just about spinning plastic in an oven. There's a lot of science and engineering behind it.
Exactly. And it's responsible for so many of the products we use every day, from those massive water tanks, to the kayaks we take out on the lake, to the playground equipment our kids enjoy.
And it's not just about the process itself. It's about understanding the materials, the design considerations, and the potential challenges that come with it.
Right. It's about appreciating the ingenuity behind those everyday objects and recognizing that even the simplest things often have a complex story behind them. I feel like I'm looking at the world with a new set of eyes now, noticing the subtle signs of rotational molding everywhere I go. It's like a secret code has been unlocked.
I love that analogy. And now that you have this knowledge, you can start asking yourself, why was rotational molding chosen for this particular product? What were the design goals? What challenges did the manufacturers have to overcome?
It's like turning everyday objects into little puzzles to be solved. For example, I'm looking at my reusable water bottle right now, and I'm wondering, could this be a product of rotational molding? It's hollow, it's durable.
That's a great observation. It definitely has some of the hallmarks. But remember, not every hollow durable object is automatically rotationally molded. There are other processes out there that could achieve similar results.
So it's about considering all the factors,
Yeah.
like the material,
Yeah.
the complexity of the design, and even the scale of production.
Precisely. You have to think like a detective, piecing together the clues, and using your knowledge of the process to make an educated guess.
I'm up for the challenge. I'm going to start analyzing everything I see now, from storage containers to traffic cones to those giant inflatable holiday decorations.
And that's what we hope this deep dive has inspired. A sense of curiosity and a desire to look deeper into the things we often take for granted.
Absolutely. It's been a fascinating journey, and I feel like I've learned so much about this hidden world of manufacturing.
And who knows, maybe this will spark a lifelong interest in exploring other manufacturing processes and discovering even more hidden wonders in the world around us.
That's the beauty of knowledge. It opens up a whole new way of seeing things. So to our listeners, we encourage you to keep exploring, keep questioning, and keep diving deep into the fascinating world of manufacturing. Until next time, keep those eyes peeled and happy molding.